If I had 16x squared minus 1, is that a difference of perfect squares? Well, we check. Is this something times itself? 4x. And is this something times itself? 1. And do we have a subtraction? Yes. So this would factor into 4x minus 1 and 4x plus 1. Those are the factors. If the book asks you to find the roots, we set both of those equal to 0, and we add 1 and divide by 4, and we get x equals 1/4. And then we subtract 1 and divide by 4, and we get x equals negative 1/4. Okay? All right, what about this one? No. Why not? It has a plus. Right. It's called a difference of perfect squares. It has to be a subtraction. The reason is, if we did 9x plus 3 and 9x minus 3, why doesn't that work? How do I know that's wrong? Is 3 times negative 3 equal to positive 9? No. Well, what if I made them both positive? Why doesn't that work? The middle term doesn't cancel. So no matter how you try to spin this, it's not going to work. Now later on, we're going to figure out a way to factor this, but it's in a totally different realm than what we're doing right now. So as of today, we don't know how to factor that. Okay? What if I had 36a squared minus 81b squared? Is that going to factor? Is this a perfect square? What is the square? 6a and 6a. Is this a perfect square? 9b and 9b, and do I have a subtraction? Yes. So this would be 6a minus 9b and 6a plus 9b. And in this case, you can't find the roots because we have two variables. You can only have roots if you're limited to one variable. Okay. The book does something a little bit interesting. It says something like this: 25 squared minus 4 squared. What is 25 squared minus 4 squared? Well, you could type it in your calculator, but it wants you to factor them. Is this a difference of perfect squares? Yes. So it would be 5 minus 2 times 5 plus 2. Right? Well, what is 5 minus 2? 3. And what is 5 plus 2? 7. So the answer is 21. That seems a little low, doesn't it? Yep, I made a mistake. Getting rid of the squares. I don't need the squares. There we go. So 25 minus 4 is 21, but if we factor it, we get 5 minus 2 and 5 plus 2. 3 times 7 is 21. Now, the problems in the book actually do have squares in them. For instance, 19 squared minus 11 squared. So this would be 19 minus 11 and 19 plus 11. 19 minus 11 is 8. 19 plus 11 is going to be 30. And what is 8 times 30? 240. Okay. The book has one other special product, and it's called a perfect square trinomial, and we're gonna start with a factor. Let's say I had x minus 6 and I squared it. If I put that in the box, x minus 6 and x minus 6. X times x is x squared. X times negative 6 is negative 6x. And then this is negative 6x, and then this is plus 36. Okay? Well, when I combine those, these add together, and I get x squared minus 12x plus 36. Well, this has a special pattern. This squared is that. And then this times 2 is that. And then this squared is 36. Okay? So the pattern is, if I cut that in half, I get negative 6. And then negative 6 squared is 36. Whenever that happens, then you have duplicate factors. So let's do a bunch of these. X squared minus, let's say, 10x plus 25. If I cut the negative 10 in half, what do I get? Negative 5. And then if I do negative 5 times negative 5, do I get 25? Yes. So this is going to be x minus 5 and x minus 5. Okay, if you cut the middle number in half and square it and you get the last number, then these will always be the same. Okay, let's try another one. X squared plus 4x plus 4. Does that fit the pattern? Well, cut this in half and you get 2, and 2 squared is 4. So what are my factors? X plus 2 and x plus 2. Okay. X squared minus 16 x plus 64. Does that one work? Cut that in half. Negative 8. Is negative 8 times negative 8 64? Yes. So this will be x minus 8 and x minus 8. Okay, what about this one? Cut the middle one in half and I get negative 5. And then is negative 5 times negative 5 10? No. So that one didn't work. So we would have to try factoring it the other way. Okay, let's try one more. Does that one work? Ooh, almost, right? We take the 18 and we cut it in half and we get 9. Is 9 times 9 negative 81? No, it's positive 81. So in this case, it doesn't work, but if this were a plus, what would the factors be? X plus 9 and x plus 9. Okay? And guess what? If you forget, it doesn't matter. You can just factor it the old way. So I draw the box, I put in x squared, I put in 81. X squared times 81 is 81x squared. And I know that the signs are the same and they're both plus. So 1 and 81, that doesn't work. 3 and 27, that doesn't work. 9 and 9, that one does work. So I put in 9x and 9x, and I get x, x plus 9, and x plus 9. So even if you forget that rule, you can always use the box and just factor it. So in your assignment today, in the first set, you're just going to factor. And then 9, 11, and 13, you're going to do that simplification to allow you to multiply those together. And then factoring, solving, and factoring. I want you to do 3. 3 through 40, 3 through 43 odd. So 2.6, no, 7. 2.7, 3 through 43 odd. All right, get to work.